So again here, we are going to look at our last relationship. Don't forget we have just looked at n1 to 2, n3 is equaling to n1 to 3 direct. This one has also been looked at. So now let's look at the third relationship, where we are going to say that consider array. Also we can say AO from air to glass and from glass to water and finally refracted in air. And then you can say that it's observed that if the sides of the boundaries are parallel to each other, then the angle of incidence is equal to the angle of emergence. Okay? It will be equal to the angle of emergence. That is when it is from air to glass and then to water and then get back to air, as we are going to look at here. So we are saying that it is very true that if I'm talking about something like this, okay? So what we are saying is that let me draw it with a better ink. If these are parallel to one another, what is very true is that if I have this and then refracted and then refracted and then finally in air, what is very true is that if this is air, this is glass, this is water, and then again back to air. So what we're saying is that if this angle is I, it is also very true that this angle here will be I. If this is air, and these are parallel, the angle, the two will be parallel to each other. Okay? If the bodies are parallel, the imaginaries will be equal, and then they'll also be parallel. That consider AOA to glass, from air to glass, and from glass to water, and finally to air. It is observed that if the sides of the boundaries are parallel to each other, then the angle of incidence is equaling to angle of emergence, since the two rays are parallel. So these two rays will be parallel. If you trace this and you trace this, they are supposed to be parallel to each other. It should be something like that if you continue with this and take this. So they will be parallel to one another. So we can now say, this is maybe say angle of refraction R, and then if this is R, just know that this one is also going to be our angle R. And if I decide to use I can say this is maybe say I1, this is I2, this is I3. Okay? Let me use a different marking to illustrate that. So if this is I1, this will be I2, this will be I3. But this angle is the same as that, and this is also I2, and this can also be I3 like that. I'm using I, you would also use R. So if I now look at the interface for air to glass interface, we shall say air to glass is equaling to, from air to glass is equaling to sine I1 out of sine I2, implying that, this is implying that sine I1 equaling to any glass sine I2 equation 1. And then I can also look for air to water interface, okay? From air, this angle here also, this angle I can call it maybe I4. I can call this one I4. So I can now say if now I'm moving from air back to air to water, it will be now sine I4. But please don't forget, we said this angle is the same as the other, therefore it can also be I1. They are parallel and they are equal. This angle is the same as that angle. So I can say it is sine I1, because it will be sine I4, but I1 is this, I4 is the same as I1 out of sine of I3. And that also implies that sine I1 is equaling to that sine I3. Let me write it in a better place here. And I say that this is sine I1 equaling to sine I3, which is equation 2. Okay? So we shall say equation 1 is equaling to equation 2. And that is saying that energy sine, this is sine I2, this is 2 sine I2 equaling to omega that sine I3, but we are saying this is the same as sine I1. So we can say, rewriting the above equation in terms of absolute refractive index, that is to say, we shall say for air we shall use any air, and for glass we shall now use energy, and finally for water we shall use any W. So that means that we should now say, if you're looking at absolute from air to that, shall say energy sine I2 is equal to now this one. Refractive index of air is also 1. So that means that I can say this is the same as NW sine I3, which is equal to NA sine I1. Okay? And now generally this one can be now, in glass we have angle I2, in water we have 3, in air we have 1. So it means that we can say that any sine I is equal to constant. Okay? And then you make conclusion that for rays traveling from one medium to another of parallel boundaries, comma, any sine I is equaling to a constant, where n is the refractive index of the medium and I is the angle of incidence in the medium. So this is also one of our important expression, that n sine I is a constant. Please take your time to make this derivation. You derive all of them, because anytime they can be asked from you, you try to derive it. We shall now look at how we can perform numerical problem, how we can have some numerical problem related to whichever concept we have tried to derive. So let's now meet for our example.